Welcome to Crash Helmet Design, Prototyping, and Testing, a safety product PBL. I'm Camille McHugh. So let's address some of the background on this theme. A traumatic head or brain injury is any injury resulting in trauma to the scalp, skull, or brain. There's multiple ways this can happen, but let's categorize them two ways. In a coup injury, the damage occurs under the site of impact, and this results from the initial impact usually being hit in the head by something. And this causes the brain to compress, the brain moves forward and impacts the skull and compresses within the head. And in a contra coup injury, damage occurs on the site opposite the impact. This usually happens when the head hits something else, for instance, when you fall or when you impact an object, run into a windshield. This will result from the brain rebounding inside of the skull. It causes tension because the brain is pulling back. The neurons and the blood vessels are being stretched. And you can see that this is additional damage, although a different type of damage than a coup injury. So think of compression as pushing your hands tightly against one another with all of the force directed inwards. And then think of tension as the opposite process, pulling your hands as hard as you can against one another with all of the force directed outwards. How do head injuries occur? Well, a surprising percentage occur from falls, about 40%. Other causes: unintentional blunt trauma, vehicle crashes, assaults, and simply other or uncategorized. You might be surprised that vehicle crashes are that small a percentage. And this data comes from the Centers for Disease Control. Who experiences head injuries, and what is the outcome? Well, the CDC states that traumatic brain injury, TBI, is a major cause of death and disability in the United States. TBIs contribute to about 30% of all injury deaths, and every day 153 people in the U.S. die from injuries that include TBI. Those who do survive a traumatic brain injury can face medical effects that last a few days or even the rest of their lives. And TBIs also result in lasting personal, professional, and economic effects. So in seeking a solution to this problem, what are some of the ways to avoid head injuries? Let's think about this three ways: system-centric, device-centric, and user-centric perspectives. First of all, system-centric means that we're just going to eliminate the dangerous and injury-causing activities. We're going to get rid of them in the world. They won't exist. There will be no such thing out there that could cause an injury. No roller coaster, no sport would exist. There would be no vehicles. There would be nothing out there in the world, and that seems rather impractical. So let's think about this from a device-centric perspective. We could place protected devices into the system, so that'd be sensors on cars, airbags in cars. And if you think about it, with crash test dummy footage that you've seen in crash tests of vehicles from the Safety Institute, you can clearly see that an airbag helps reduce or eliminate injury to an individual involved in a car accident compared with an individual who does not have an airbag in their car. And lastly, we can look at this from a user-centric perspective. We could just say, well, as people, we can make choices not to participate in those activities. Or we can place protective devices on us that in some way give us some degree of protection so that we can engage in those activities. Jerry Seinfeld has some interesting commentary on those types of devices.
The fact that we had to invent the helmet. Now, why did we invent the helmet? Well, because we were participating in many activities that were cracking our heads. We looked at the situation. We chose not to avoid these activities, but to just make little plastic hats so that we can continue our head-cracking lifestyles.
So the goal of this project is that this is an authentic task for you. You will design, prototype, and test a protective crash helmet. An egg simulates a human head. The egg will be dropped from altitude via a ladder onto a hard surface, and the crash simulates an impact accident incurred by an individual which may result in a traumatic head injury. Now, as we approach this entire process, we must engage design thinking, which means we don't just jump to the end and say, this is what I'm going to make. This entire project simulates the kind of design thinking in which you'll engage if you are a product engineer. And keep in mind that design thinking really consists of 5 stages: empathize, define, ideate, prototype, and test. And in this stage, we are working on empathizing. Empathizing with the situation, empathizing with the problem, and specifically empathizing with the individuals affected by this problem. So what do we do in the empathize phase? We interview people who have been impacted by this. We shadow them to see what their lives are like. We seek to understand their situation, and we're non-judgmental in our opinions about them and their experience. We'll be talking further about the other stages of the design thinking process as we move throughout this process on the project. But let's think a little further about empathizing. Your first task is to do a little bit of research online. Think about those other categories. We already know that falls constitute a large percentage of traumatic brain injury, as well as, to some degree, vehicles. But in the categories of other causes and unintentional blunt trauma, what are some of the specific less frequent causes of TBI? I want you to be specific with regard to sports, accidents, job-related sources, and what age groups experience these TBIs. Remember, in this phase, we seek to understand and we are non-judgmental. Secondly, I want you to research some more and describe and quantify the effects of TBI. What are the specific medical effects resulting from a traumatic brain injury? What are the lasting personal and professional effects resulting from a TBI? And I want you to quantify these effects economically as best as you can. I want you to assemble your research into an individual work product. Each of you will create an empathy infographic. Create a visually impactful single-page infographic depicting a summary of your TBI findings. Here's what you need to use: an appropriate title, limited text. This is not an essay, this is an infographic, and correct spelling. You can assemble this in landscape or portrait orientation. You need images or drawings, if you choose to draw, of at least 3 causes of TBI and the affected age groups. And images or drawings, descriptions, and data, charts, and graphs highlighting the medical, personal, and economic effects of TBI. You should be able to scour the web and find all of these pieces in some form or another and simply assemble them into a logical layout. You can create your layout for your infographic in Google Slides, Photoshop, Illustrator, any of those, and then output it as a JPEG, PNG, or PDF. Remember, in this phase, we seek to understand and we're non-judgmental. Good luck in executing this first phase of the design thinking process. Empathize.